Alrighty, this right here is the equation of a pizza cooling down after you take it out of the oven. So at what rate is the pizza cooling? It's that percent right there. It's a continuously decaying by 9%. It's continuous because E causes a continuous decay, 9%. It's actually a decrease, but that says cooling, so decay. So you could put a negative if you want, don't have to. How hot was the pizza when you pulled it out of the oven? Well, when you pull it out of the oven, that would be times 0. So I've simply put 0 into the function. When I put in 0, this right here becomes e to the 0, which is 1. So I do 220 times 1 is 220, plus 80 is 300 degrees. That's a really hot pizza. There's probably a problem there, but okay, we'll just go with 300 because that is how the calculations work, even though it's not very realistic. All right, you could also find the temperature when you pulled it out by just simply adding this number A and the K. That's a shortcut to find y-intercepts. Or plug in 0, your choice. Next, what is the temperature of the room? Well, the temperature of the room is, as it decays, what are you approaching? And you're approaching 80. Because really there's an asymptote at 80. So you're approaching 80. It's never going to get below 80, but it's dropping closer and closer to 80. So that is the temperature of the room. So for the next problem, why won't the pizza ever be hotter than 320 degrees or colder than 70 degrees? Well, basically because if it's the oven is 300 degrees, or I should say when it comes out of the oven is 300 degrees, and if the room temperature is 80 degrees, how are you going to get below the room temperature, and how are you going to get above what you take it out of the oven at? It won't keep going up in temperature. So you have to stay between these two numbers, and both of these are outside of that logical domain. Remember, this is an asymptote, so you can't get below the asymptote. And this is your initial time, so you can't get above the initial temperature at the initial time. Lastly, how long will it take for the pizza to get 100 degrees, which is hopefully edible at 100 degrees. So what I do is I simply put 100 right here for P of t. So I put 100 minus the 80, get 20. Divide by 220. When I do reduce this, I get 1 over 11. This right here, and I get this right here is 1 over 11. Then I change it to a log, so I put log right here and switch these two. When you do log base e, it becomes ln. And then to get rid of this, remember you move this over, and you move this into the log. Now to get rid of this negative 0.09, you divide by negative 0.09. And then if you put this in your calculator, you get 26.64 minutes. So if this is accurate, it takes 26 minutes before you want to eat your pizza. Something's wrong. Either my rate's wrong, or the 300 degrees when it comes out of the oven, which is preposterous, is wrong. So good luck with this problem.